Alright class, video number 2 for our helpful videos, part 1, talking about inclined planes. So what I'm going to do in this video is I'm going to show you how to break up all the different parts of the forces in this inclined planes. And at first glance you'd say, well, there's not that many forces. There's really only one when you think about it. I mean, if there's a, that's true, there's two. When you think about some kind of object, we'll just imagine a box on a ramp, kind of like what I showed you in the last little video. There was an object on a ramp. We have two forces. We have this force of gravity, which is pulling it down. So there's this force gravity. It's pulling it down towards the ground. And then there's the force normal, as in the board is holding up. It's not breaking through the board. It may be sliding down it, but it's not breaking through it. So there's a force normal. Now, like I talked about in the other video, force normal can only act at like 90 degrees to wherever it is. So what I mean by 90 degrees, if I'm just going to get a little ruler here. If I have this ramp here, it's going to sit like at 90 degrees on top. So it's not going to be in the same direction as the force of gravity. It's going to be in this direction. This is our force normal. That's how the actual, that's how the force is acting on the block. So we talk about, again, go back to even to Newton's laws. Every action has an opposite reaction. Well, we have the force of gravity. There's a reaction. The board is still going to hold this object up, but it's going to act at 90 degrees there. So those are really our only two forces. There's no force applied. No one's pulling right now. We're just talking about an object on a ramp. So how do I actually figure out eventually, like, acceleration? Is this thing moving? For now, let's just draw all the other forces that are going to be on this. Well, again, if you think about this, like, which way is the board, is the object going to move? Well, it's going to move in this direction. It's going to go down the ramp. So we need to find something that's similar to kind of this direction. And we'd also like to find something that's similar to the force normal. I want to find what force normal is. Obviously, it's changing. When it's at 0, it's the same as force gravity. If I go all the way to 90, it's nothing. So I want to be able to find that. So and this is how we break it apart. We're going to break and make a triangle right here, as in this and this. I'm going to kind of try and use two different colors for you. That way, because I look, it's a little dotty on there. I'm going to use a black and a green here. Hopefully you can see better. We're going to turn this into an actual thing. We're going to turn this into a triangle. All right, hopefully you can kind of see. That's black line, green line. Our black line is going in the exact same direction, the exact opposite direction, but the exact same angle as our force normal. So we can use this to find our force normal. And the nice thing is when we also turn this green line is going the exact same direction to our dotted line here. Now that I kind of look at this, it's kind of hard to see that dotted line, but I made a dotted line here. Dotted line. Maybe that'll be easy because, again, that's the direction the box or object is actually moving. So this green line is going to be in the same direction, okay? There's a specific force word that we use for this. We call it force parallel, like with a P. The reason is because that parallels this, in the sense like they're exactly the same angle. So that's what we're going to use. We're going to use force parallel, P. So force normal, nothing's new there. That's not a new term. This is exactly the same as how much is pushing back. This force parallel is a little new, okay? The 30 degrees, where does our 30 degrees go in here? It attaches to the where the box is up here. So this is our 30 degrees. I'll put 30 degrees. So this is the same as the 30 degrees. All right, how do we actually find these two things now? How do I find force normal when it's on an inclined plane and force parallel when it's on an inclined plane? Because those will go into our formulas here. You can kind of see there's some formulas there that I got up there. There's our two from last week, but that's only if there's a force applied. There's no force applied this week, so we got to make kind of some new parts. When you're on an inclined plane and you're trying to find this force normal, well, I have an angle here. The nice thing is let's give this a mass to make this a little easier to think about. Let's say I have a mass of 20 kilograms. Okay, how do I find force gravity? That never changes. Force gravity is just like 9.8 gravity times 20, so that gives us 196 newtons. Okay, so let's call this 196. Well, this is the hypotenuse. That 196 is my hypotenuse here, so that's good. I have my degrees. If I want to find force normal, that's our adjacent. Again, I told you how trig never goes away, never goes away. Force normal is our adjacent side, which means we're going to use cos. So to find force normal, and I just want to change this to a black to make it similar to our nice line. Force normal, when it's on an inclined plane, is going to be cos theta times force of gravity, because we're breaking apart force of gravity. Last week, when we were breaking the angles apart, is because our force applied was at an angle. This time, our force of gravity is going to be broken into different parts for angles. So that's how we find our force normal. Cos theta times gravity. You can kind of see hopefully where I got that from here. Our force parallel is our opposite side. So that's going to be our sine function. Our force parallel equals sine theta times force gravity. All right? So that's how I break this thing up. All right? The last thing that you'd have to do is if there's a question of like, how fast are they moving? Again, usually you're going to have, and I'll hopefully try and put this in red here. You're going to have force of friction possibly. Force of friction. Again, anytime two objects are on each other and they rub, there's going to be some friction. That doesn't change nicely. Force of friction formula is just mu times force normal. So I would have to give you a mu in the sense of, let's say mu equals 0.30. I give you this, and you have found force normal. And that's what was changing when I was moving the angle up and up and up. Sure, I got a little more force parallel in the sense of like gravity was helping the object come down. But as well, my force normal, as you up, keeps getting smaller and smaller and smaller, which means that force of friction gets smaller and smaller and smaller. All right, so I'm going to go in the next video. I'm going to actually answer one full question, but here's how you break apart all the little forces that are needed in here. So you'll have force of gravity. From that force of gravity, we can break it down to force normal, force parallel, which are those. And then if we eventually want to include force of friction in there, the nice thing is that doesn't change too much from what we've done before. All right, perfect class. Next video will tell you answer one of these perfect questions, and I'll probably take it exactly from the worksheet that I have in the file folder. Thanks, class.